Look, the purpose of this afternoon's session is to give you an update on the development work that we've been doing over the last 12 months. The content that we had this morning and the presentations that we had this morning were a good segue into a lot of the development work that we've been doing. So it's been really good that the things that we've been working on is actually what the industry is asking us to look at. So we started the initiative really with the launch of our first forum back in November 2010. And the things that we focused on was really three core strategies. So the first of those was we're going to focus on a single, we were going to be vendor independent, but vendor specific workflow. So what we were going to focus on was Revit all the way. And with that, we haven't had any, received any financial support from Autodesk. But more important to us is the technical support and the development work that Autodesk are doing to support the initiative. The second thing that we've focused on is this development of the Constructible Revit template, and today I'll show you some of the work that's actually been done with that template and the use of that template. And it was really good today to see some consultants actually talking about how they're starting to use that template and the benefits that they're getting out of it. And the third thing that we said that we would be doing is focusing on the supply chain integration, which again, when Dominic was talking, he was starting to talk about the importance of the supply chain and the processes of off-site manufacture and all those sorts of things that actually get the project built. So there were the three things that we were going to focus on. What we weren't going to really look at was all those real sort of design tools. So those sort of software developments around thermal modelling, energy analysis, fire safety engineering, all those sorts of things. What we wanted to do was provide a solid platform to do the actual modelling, and then others to look at the tools that leverage off a solid platform. So in terms of our development plan, you need to focus on the things in a sequence. And I guess in some sense this initiative has been driven by the contractors and the installers. So what we did focus on was geometry and workflow integration. We've made very significant progress over the last 4 years, but really what we're starting to hit now is data. So businesses are getting the geometry and the workflows working, but the real challenge moving forward and the next phase of the journey is to really get mileage out of the data. If we make the same progress that we've made in terms of geometry and workflows that we have in the last 4 years, over the next 4 years in terms of data, we'll be in a really different place, a good place to be. And once we've got those, and they don't all work one after the other, they sort of overlap, but once we get the data and the geometry and the systems working, we can start to look at the engineering of systems and really start to look at leveraging BIM-FM. So that's been our phased development plan. And as I said, I think we've made pretty significant progress in terms of the workflow integration. But the thing that we've been really focusing over the last 6 to 9 months is what we're going to go and do about data. So just to bring you up to date on Revit MEP all the way. This is the workflow that we said that we'd focus on, where we have a design model that's done in BIM, somewhere between LOD 100 to 300. And from that we would do a virtual build, and we would end up with an LOD 400 construction model. And that construction model is actually the platform on which we build our projects. Okay, that's the platform which we drive scheduling, we drive procurement, we do all those things. And if, in regards to the LOD 400, if we use Constructible Revit modelling, we basically get the as-built model for free as a free deliverable. So we focused on that. In 2013, and I'll show you some examples today, we got Revit piping. all the way, and I'll show you some examples of how that's been working on different projects. And the only thing that we're now really focusing on in terms of fabrication and moving stuff out of Revit is for ductwork fabrication. So that's 2013. So here's a constructible Revit model. This is the prefabbed riser on Bendigo Hospital. It is fully constructible. Every single piece on that model can be fabricated by the machines down at one of the duct makers or cabinets or any of our supply chain. One of the differences here is that every service here is modelled in a particular specification. So if you're modelling piping and you're just showing a pipe, and you're not detailing what the material is or the working pressure of it is or what the fitting part numbers are, then it's of very limited value. Basically, it gives you a line on which you then have to remodel it. So all of the services in BIM-MEPAUS are to be manufactured or incorporate a specification. And the learning from that actually came from when we went down to duct makers and actually understood that how they actually, when they get ductwork, they actually then go and start applying specifications and services. So some of that fabrication learning we've brought back into our Constructible Revit templates. The other interesting thing about this module is that we actually fed it back to NDY and they incorporated it into their services model. So that's an example of good use of a collaborative design approach using a single integrated template. Here's another example. So this is an AECOM model for the Telstra data centre. Really pleased to get it. This is a fully constructible piping model for the same data centre. We got a return on investment in taking this model and converting it to constructible Revit modelling of a ratio of about 4 to 5 to 1 on what we invested in terms of that virtual build process. Here is a fully constructible Revit piping drawing. Every element in it is scheduled. Everything was delivered off that Revit construction model. We also procured off this model, so all of the fittings were scheduled off the model, all the pipe lengths were sent to the manufacturers, all the piping was rolled. It was all delivered off a Revit construction model. Here it is actually installed and dimensionally and accurate to within about 2 to 3 millimetres. Here's spooling, stainless steel pipework spooling, again all done in Revit with no fabrication and no drawing and no rework. But the thing that you really need to understand is why is constructible Revit so important, and it's because this. If we don't get it millimetre perfect, it doesn't fit on site. Okay, and when you're dealing in heavy steel pipework, issues like this are a problem. So the other thing that you need to understand is that we're bringing all of our, someone was talking today about QA. So all of our QA is actually being brought into the BIM environment. So all of these checks that we need to do, like working pressures, making sure that we've got the right fitting, not a fire fitting instead of a mech fitting, all of these things need to happen in the model space, because once we press send, that's what's coming to site. So for us, a Revit construction model is actually the platform, as I mentioned, that we actually deliver the project on, and it has to be right. So that's where we've got to in terms of the workflow. In terms of our development work, we've probably been heads down quite a bit over the last 9 to 12 months, but there's been quite a it's been quite interesting over the last 1 to 2 days, just people talking about the issues that we've been working on. So that's been good. So the first thing that I want to talk about is the national template that we've been working on and content. So We've done a lot of work. Brendan from A2K has been working. We've had the user groups providing input. We've made a lot of progress. We still recognise that it's predominantly mechanical services, and so over the next 6 to 12 months, we want to certainly get the fire side sorted, and then we want to start looking at electrical and the other disciplines. What the thing to understand about the template, though, is it is actually the foundation for workflow integration. Okay? What we saw this morning where we had wood and groove using the template and the mechanical contractor taking it without reworking it, without re-entering it, might have tweaked it. It all depends on the use of a common template. So we've made quite a bit of progress in this area. We've also, A2K have written a guideline for the template, which is good. We do have a bit of work to line up some of the specifications with the content, and we'll tidy that up over the next 3 to 6 weeks, hopefully. The other thing that around the template is that obviously the BIM-MEPAUS template sits over Autodesk Revit MEP. And obviously people were talking today about their hybrid templates. So we want the BIM-MEPAUS template to be, if you like, the foundation template, and we understand that the content, other people may want to add content to their templates, but what we don't want you to do is to modify what's in the template. So if there's a ductwork family, we don't want you to make your own ductwork family, because when it comes down to us, that'll start to generate issues, because we can't actually make it, is a typical sort of issue. So we're all for hybrid templates, but the real thing that what we're trying to do is, if you look at a lot of firms, their cost to maintain their templates and to work in Revit is an ongoing, sometimes sort of increasing sort of cost. Actually, what we want to do for the industry is to bring down the cost to model in Revit, and at some point to reach a much lower cost base, so that basically it's just a maintenance activity, it's not a development activity. So that's what we're focused on. As I said, we're looking to extend it and to other services. It was always intended to be a multi-services template, but it's best to inflict all the pain on mechanical and then move to other disciplines, and I think we've now got it right, so we're ready to roll it out. So just in terms of content, templates and contents go together. And this is basically representing content-induced migraines. And if you look at the industry, everyone who works in BIM modelling understands what I'm talking about. So the thing is, if you look at this model, so this is fully constructible piping, but we've got content from one of an American chiller manufacturer, no content that we can use. We've got pumps that we can't use, and we've got tanks that we can't use. So any end-of-line equipment, we haven't been able to get the content. So at the end of the day, we've done what we needed to do basically our piping modelling. But it sort of, in a way, it demonstrates the issue that the industry faces. We've spent a lot of time looking at what to do about content. So we've looked at Open BIM and IFCs and ISO standards, and all of that stuff sort of is, in some sense, obviously we support open standards, but it's pretty complex space, and it's pretty hard to actually find the right, an industry solution that works for us in the short term. The interesting thing is that when you look at content, and here I've picked an axial fan. An axial fan is basically an axial fan is an axial fan. So these fans, I've got fans here from China, I've got one from Australia. You can work out which one's the Fantech one. I've got ones from Brazil, I've got ones from Europe. They're all over the world, but basically they're all the same thing. They might have different blades, they might have different colours, but as you notice, they've all got a ring on the edge of them because they've got to connect to ductwork. They've all got the same holes. Okay? What's interesting is there's probably, I don't know, 100 fan manufacturers around the world. There's probably thousands of axial fan BIM models. It's crazy, right? We talk about this morning that the construction industry hasn't moved in terms of its productivity, and we're just replicating that in the BIM world. It's nuts. So in some sense, you know, Revit, when it started, you know, it's a project modelling environment, but it also, because it is BIM, you know, it's got all the tools to make families. And in some sense, that's probably because we can't get the manufacturer's content, for all sorts of reasons, everyone's off making their own families. And really, what we need to do is turn the industry around. We really need a fresh start on our content strategy. And this is what the problem is. So it's basically what we call content poker. And if you're a BIM modeller, you know that when you get a piece of content, you look at it, and there's probably three things that you're going to look at: geometry, connectors, and shared parameters. So don't worry about the shared parameters because it's not going to be what you need. The next thing is the connectors. May or may not be right, who knows? Geometry may or may not be right, who knows? Does it host properly? All these things, right? You look at the way that, and I spent a fair bit of time looking at my BIM modelers, you look at them and they get a bit of content and they actually have to discover how it's built, what the person who made the family's done, whether it's right or wrong. And more often than not, it's a total wipeout. But what you really, and for us, whether you're a consultant or you're a contractor, you're putting money in, and you're putting lots of it in. We don't know exactly in our business how much it's costing us, but I reckon it's costing us hundreds of thousands a year. Right? There's got to be a better solution to the issue. So what we've done is we've worked with Autodesk to develop a new content delivery strategy. So BIM-MEPAUS is going to provide Autodesk with industry-based specifications, and Autodesk are going to build us a source set of content. And A2K are then going to add a master set of shared parameters to it. Doesn't seem that difficult, but evidently quite revolutionary. So BIM-MEPAUS writes the specifications that you've probably seen on the website, and basically they have some application guidelines for engineers and bits and pieces. They have the shared parameters. We also produce an IFM schedule. So this industry foundation model, what we're providing Autodesk is an industry-based set of standards or structures to the families that you as an engineer or you as a modeller would know, yeah, that's actually industry-based content. And we also provide Autodesk with some advice in terms of how the families would be used, what they're connected to, and all those sorts of things. Here's the guidance that we've provided Autodesk in terms of that axial family. And basically it's based on the ISO standards. Now generally we don't have that many sizes in a family. Generally we try to get down to about 5 to 6. But if you're in design modelling, it's more than enough for you to do what you need to do. Autodesk then give us a foundation model which has the geometry model to an industry standard or a reference manufacturer. It has the connectors set, it has the Revit functionality correctly done, it's constructible, and it has some core parameters to it. Here's the fan that we've got, one of the first pieces of content that we've got from Autodesk. It's an axial fan. It is not the most beautiful fan. The content that Autodesk is building is lean geometry, okay? We'd much rather trade niceness, in terms of looks, for data. Okay, so this is around 385K. It's got an access zone on it. You know, it's sort of, you know, it looks about as nice as a US Army Jeep, but, you know, it does the job. Okay, and it carries the important information and the important geometry that we need. A2K then add the shared parameters to it and then publish it on the website. Okay, so now you've got a fan that is a workhorse. It can carry all the information that you need it from whether you're a designer, a contractor, a manufacturer, a facility manager. Okay, it's all based on industry standards. This model was 445K. Another industry model that we sort of recently received for the same thing was more than 650K. So even with the data, we haven't bloated the model. So now, all of these fans all around the world, ideally, our vision is that they all have the same DNA that starts from this single model, right? If you want to model an axial fan, don't go and make your own family. Go and get this BIM-MEPAUS one. Okay? Right? Because it will do what you need it to do. You know, and really, you know, from Autodesk's perspective, that should really cover every single fan that's axial fan that's ever been made anywhere around the world. So what are the benefits? It's best of breed. It's a single reference point. So, okay, if the content that you get is not right, you know, tell us what's not right about it or what needs to be improved, and we're fixing a single model, not 5,000 models all over the place. It's fit for purpose. It should reduce your cost to get engaged in BIM. It should make it much simpler for manufacturers. It should make it much simpler for designers. And it supports supply chain workflows. So the other key to content is, and we talked about this about 2 years ago, is that BIM-MEPAUS has broken up content into fittings, equipment and plant. Right? It's totally, when you look at it, it's not a really good fit with most other classification schemes, particularly in Revit, but we're going to stick to it because that's what the industry understands. So when you look at fittings, right, this is things that go into piping systems. This is a fully constructible fire pump room on a Melbourne data centre. Okay, but the thing is, all that you really need to know is how many fittings you've got of a particular type and where they go. Okay, so we need to know the working pressures, the pressure losses. It's pretty straightforward. When you get to equipment, that's things like VAVs and thermal and fire dampers and those sorts of things. What we're expecting is that manufacturers will have a catalogue for a particular product range. And if you're a designer, you'll get the correct size from that family and you'll insert into the model. One of the things that we would like to be able to do is to lock the geometry so that when you insert it into the ceiling space in the virtual world, you basically lock it in the physical world. Right? It's very easy to change something in the virtual world, but causes chaos when you actually get to this out on site, and someone who just changed it because they could, well, it's not that easy to change it in the field. So it's pretty important to be able to lock it down. And as I said, but what we do want to be able to do is we do want to be able to provide access for engineers and modelers to actually schedule those things that they typically schedule. So on a VAV terminal, you normally want some flexibility. They'll have an airflow range. You want to nominate the actual design airflow of that, and hopefully it's within the, or preferably within the design range. So we think that's the way forward with equipment. The big thing that we're looking for is content configurators. So this is sort of a concept that I think Chris Diorio and myself sort of talked about in AU last year. But basically it builds on what Fantech already do for the industry. So most engineers on their desktop would have a Fantech selection button and different manufacturers, right? Their IP is in their selection software. At the moment, what they can deliver to you is a drawing, but what we want is actually in the future is we need a BIM model. So the future that we think is, the future's not in creating new families. The future is in, for plant, is in these content configurators. So you have proprietary software of the likes of what Fantech has. It adds schedules from that selection to the manufacturer's certified content. So that content is as accurate as the drawing that you had, and they have the ability to export that to your project. So everything, ideally, that say a Fantech can do in CAD world, we need it in the BIM world. And we believe that that's the future of how content should be delivered to the industry. Just to put that into a workflow context, we've actually put this in our guidelines, but basically, because we've now got a single point of truth or source in the fans, content works with the template, and it provides a platform for designers to actually schedule in generic content, the schedules, or the plant and the equipment. From there, when it comes to the consultants and they get the model, they can extract the data from it. We can send it to the manufacturer and the contractor can finalise the selection, and then the plant supplier can export to us manufacturer's certified model, that we change out the design model with the manufacturer's model. Because they've both got the same DNA, that should be a seamless process. Okay? None of this endless frigging around that we're doing at the moment. So that's our vision of how plant in particular will be delivered in the future. So less time on content creation, more time on engineering and value adding and value engineering. So the second thing that we've been focusing on is shared parameters. So BIM with no information in it or no data is really just 3D CAD. Okay? And a lot of what you see is 3D CAD masquerading as BIM. We went and we looked and we looked and we looked and we talked to lots of people to try and find this master shared parameter file, because you'd think that it'd exist. The best that we found was in ANSYS, who actually explained the concept of the shared parameter file. And they have a probably because they're architects and we're more engineers, but they have a good list in terms of the doors and architectural things, but probably a little bit light on in terms of services side of things. So we've developed our own list, sort of as close as we can make it to the ANSYS standard. The master shared parameter file is structured to reflect established practices and workflows, and it provides a single controlled reference point for all shared parameters. So if you want to find a shared parameter related to MEP, we want to provide you with the reference terminology and the reference shared parameter for that parameter. So, you could call it air on coil temperature, or you could call it supply air temperature, or you could call it all sorts of things. We want to give you the definitive name for that shared parameter. We've structured the shared parameters so we start with identity. We've got a short section on BIM classification. Analysis returns the values from a Revit analysis carried out on the system. We've got space for green building properties. We've just got to work out what they are. We've got a whole lot of design parameters and quality parameters. You typically get extra data from a manufacturer. That's where that lives. We've got a place for commissioning, and we've got a section for handover. What we want to do is we want to park all of those, or prioritise or structure the shared parameters on the Revit content, so that if you're a user, a scheduler, this is how you see the data structure. You don't see 400 parameters on how to actually create the geometry, because that's a dead issue. Okay, that's been resolved. Right? This is the stuff that people who are working, adding value, doing the engineering, doing the procurement, these are the parameters that they want to look at. So the other thing is some of these lists can get quite long, and but the point to understand is that you should only ever enter the parameter once. Okay? No one has to fill out the entire schedule. These parameters get added progressively. So here's the identity schedule. We've got this, and basically when you look at those shared parameters, I think anyone in the room would look at those and go, yeah, I understand how that's going to work. Okay? A designer would fill out the design parameters. Typically, it gives you the unique component name like chilled water pump 32-4 or whatever it is. It tells you where it's located. It tells you the area served. It tells you which switchboard it's coming off. Manufacturers' parameters get added from the manufacturer's content. And then finally, if you have some special requirements, so like I know NRA and others have got things like barcodes and RFID codes, those can get added as well. But I think you'd look at that and go, that's pretty lean, but it does everything that we need it to do. Here's the completion schedule. So again, we've looked at COBE, we've looked at some of these other things and go, I don't think the industry is really going to have that much commitment to fill these things out, but this is not too hard. So who's the designer, who's the installer, who's the client, installation date, warranty date, how long is the warranty, and expected service life. There's not much you can't do with that data set. So it's BIM FM ready. Here's one for an electric motor. Again, most engineers would look at it, most suppliers would look at it and go, yeah, that's a pretty fair set of data. I may not need it all the time, but sometimes I might need one or all of those parameters. So it's well structured, it's logical, you'll be able to find what you want. So when you get to fittings, the parameters are pretty short. Okay, there's not that much that you need. You need the size and the geometry, you need the material, you need a product code. We're trying to sort out a product coding scheme at the moment. You need the pressure loss, you need the pressure rating, the mass of the fitting. So it's not, most people would think that's pretty reasonable. For a piece of equipment, it's around 10 to 25 parameters. You probably most people would look at it and go, that's pretty reasonable. When you get to plant in particular, most consultants would be surprised that you need somewhere between 100 and 120 parameters. But I'll just explain to you why it's at that sort of number, and you'll start to understand. So to get this pump installed, we've done a lot of research, we've looked at it end to end. It is around 120 parameters to get that installed. You know, the first problem that we typically get is that we might get about 4 or 5 parameters from a consultant, mainly the flow and a few bits and pieces. You'll find information scattered throughout the specification in different parts about the motors, the vibration isolation, all this sort of carry on. And then sometimes even you have to go and look at the drawings to work out whether it's an inline pump or an end suction pump. Okay? So that starts a whole chaotic process in terms of tendering. But then when it gets into contractor land, whatever problem the consultant thinks he's got, or she's got, it's nothing compared to what the contractors have to deal with. And when I came from consultancy to contracting, the thing was I just didn't realise how hard it was actually to get this equipment procured and installed. This was a bit of a mind map that we did at the start of just the processes around scheduling of equipment within our business. You know, in terms of we get the data, we've got to enter it into an engineering database, then we've got to get it into the drawings, then we've got to schedule it, we've got to extract it for commissioning, we've got to get commissioning field records, we've got to get them into O&M manuals. It's a nightmare. So what we're now talking about is a single Revit all the way data set, and basically it's a single point of truth. What this is worth is about 50 to 70% saving in data entry. So if you think it's 120 parameters, you know, we're saving 120 to 200 odd parameters that we re-enter. Okay, so it's really high payoff. The other thing is that we get reliability of the data. So we enter it in the consultant enters some of the data in the design model, the manufacturer adds a whole lot of data, and then we go out to field, we get the commissioning results, we get the serial number, and we push that back into the model. So it's all going to get carried, in our view, should get carried in the Revit environment. People say, oh, well, you know, maybe we have our own database and all this, and then people go, well, it's really easy for other people to start mucking around with shared parameters and all those sorts of things. The reliability of the workflow, if we carry the data in the Revit model, will be much higher. It provides a single point of truth. So this is why it's important that we sort this out. So as I said, we take the data out of the LOD 400 model, we use it for field commissioning, we get the commissioning data back and we push it back into the model using iPad technology. So to get it from a construction model to an as-built model, we should have to do very little work in terms of converting that model from the construction model to an as-built model. The only thing that we have to do is to really push back the commissioning data, and that's about it. So the other thing I just want to share with you today is you know, there's quite a few projects now using this integrated workflows, and some of the biggest projects in Australia. So I just wanted to share with you quickly some lessons that we've learned. So the most important thing is that virtual construction leads site construction. The second is that really project success will now be defined by the design and model management. Okay, so most builders can build pretty quickly, but the real key is the management of that virtual build process. Okay, and it's a complex space. And finally, resetting design and construction roles and responsibilities to reflect virtual construction is something that the industry is still learning about. But jobs that set it up correctly are doing really well, and those that don't get it right are really struggling. So just to explain a little bit more of this. So virtual construction leads site construction. So when I was in the US, I thought all these guys were busting their nuts to get this onto the top deck to save labour in terms of drilling from underneath. That's part of it, but the real thing is that it totally changes the way that the works get sequenced on the floor below. Okay? And in the US, you see that the good contractors manage the design process to make sure that they beat the concrete pour. We haven't worked that out here very often. We thought that the other thing that we thought was that when we started out, we were a bit annoyed about the fact that the consultants had these really good models and they were just giving us 2D PDFs, and then we had to try and assimilate all that information and then start redrafting it. We thought we were saving time in that process. Well, that's important, but what we really need, what the real kicker is it's the ability to get ahead of construction, because that's when you can do smart stuff. So the fact on the piping job that you saw before, the fact that we were ahead of construction meant that we could actually do significant VE and get the hangers in and do all those really good things, but we had to be ahead of construction, okay? So if the structure's already at level 4 and you're appointing your subcontractor, it's not going to be, at best it's going to be an average outcome. Okay, so early engagement of the subcontractors is really important if you want to drive down costs. Now, the thing is that Carl put this up a couple of years ago, and it's a really good slide for explaining BIM-based workflows. But it probably, in some sense, suggests that it's a bit of a linear process. This, what we're finding, is it's not a linear thing. And in actual fact, it can do you a whole world of good, but it can put you into a whole world of pain as well, right? Particularly when you get into virtual construction. So the skills that you need to build a building are not the same skills that you need to manage the design, okay? And mixing design and construction people together is interesting. So the critical thing now is in these sorts of projects is that project management skill now really needs to focus on this development of the design model into the construction model. Okay, that's where the real gains are made. That's where the real complexity is at. People talked about LID a couple of times today, and in some sense it hasn't generally been terribly favourable, but no matter what it is, what you need to understand is that one definitive, saying it's LID 300 or LID 200, some things need to be LID 400 very early in the piece because you're building slabs while you're still finalising design. Some things just need to be LID 200 and the contractor's happy. So the real smarts are where they mix this up. No one go, if you say, oh, the consultant's got to deliver LID 300 on a certain date, you don't understand what you're doing really. So the other thing is design management, modelling and core competency. So the other thing is, with all this BIM stuff, it's really good, it's really exciting, but the real thing that gets projects designed and built is core competencies, whether that's engineering or it's construction, shop drawing, or it's any of those sorts of things. This is just a tool, and what you actually still need is core competencies to deliver projects well. And the thing is that I suppose what we're really focusing on at the moment is not diluting our core competency skills because we're focusing on BIM. So core competencies are what deliver projects ultimately. I just want to give you one example of how far we've gone. So this is Bendigo Health. It's been delivered effectively remotely in Bendigo. It's NDY and it's ourselves, and involves collaborative project design. not IPD, we'll just stick to collaborative project design. So the thing is, here is NDY's model using the template. When we got this model, we could have taken this model and we could have built it. Okay? Here's the AG Coombs model. It's virtually the same thing. All we've done is some VE. So if you were a consultant and you delivered that model, you'd be really proud, right? We could build that model and it would be clash-free and it's all constructible. Here's our model, here's our model. And all we've done is we've just straightened up some ducts here and done a few bits and pieces. But it just shows you how far we've been able to come in 3 to 4 years. So that's just some final words of wisdom, because I like that. You know, we had Balfour Beatty a couple of years ago present. And I guess the thing is now, this LAD 400 model here, it is the construction platform. It is what drives what we deliver. The other thing that I think we've found through this forum and certainly internally is that BIM really can change corporate culture, and it is really a platform for innovation. But I think the thing I just want to close on is the other thing to recognise for all those involved is that the more we commit to Revit and use of Constructible Revit, the more we're committing our businesses as a business platform. Okay? So it needs to be constructible, it needs to be resilient, the platform that we use, it needs to do what we need it to do. So in some sense, things changing everywhere is really good, but what we really need to recognise today is that for most contracting businesses, the Revit construction model is their business platform. So that's us. Over the next 3 to 4 weeks, we'll be finalising the development of the new website, and we'll be publishing a lot of the new standards. We've certainly developed the template a long way, and Brendan and ATK are working really hard on it. The thing that we really want to do is get a couple of really good content configurators up, and when we get that, I think we're on the way to a really good place. So thank you very much.